Good morning, kiddos. Today we are going to go over our geometry postulates that will help you on the test. So this is our first cheat sheet out of 2. Okay? So number 1 says the points of a line can be matched one-to-one with real numbers. The real numbers that correspond to the point are the coordinates of the point. The distance between points A and B written as AB is the absolute value of the difference of the coordinates of AB. Okay? So this is the ruler postulate. Okay, and what this means is that if you have a number line and you have a point B at, let's say 2, this is your point B, and then you have a point A, let's say at 0, then you would take the absolute value of your first point, so B, which is 2, minus your second point, which would be 0, the absolute value of that. So 2 minus 0 would equal the absolute value of 2, and the absolute value is just the distance from 0, so it makes everything positive, so this would just be 2. Okay, number 2 says if B is between A and C, then AB plus BC is equal to AC. If AB plus BC is equal to AC, then B is between A and C. Okay, so this is the segment addition postulate. Okay, and we've seen this before. It's where we have a segment. In this case, it says that we have a segment AC, and there's a point B in between that. So we add the first chunk plus the second chunk, and that is equal to the whole thing, AC. Okay, the third one here, this is the protractor postulate. And this says that if you have a protractor, okay, so it goes 0 to 180, okay, so I'll put 0 over here, 180 here. It says that if you have a point 0 right here, or a point O right here, and a ray with a point like B on it, then there could be a ray somewhere between 0 and 180. It doesn't have to be right here, but it could be anywhere between 0 and 180 with a point A on it, and you can measure that with the protractor, okay? The official definition says, consider OB and a point A on one side of OB. The rays that form OA can be matched to a one-to-one with real numbers between 0 and 180. The measure of angle AOB, which can be written as the measure of angle AOB, is equal to the absolute value in the difference between the real numbers matched with OA and form OB on a protractor. Okay, I thought that was a little confusing. I think this is a little bit easier to understand. That you have a ray OB and ray OA can fall anywhere between 0 and 180, and we can measure that with a protractor. So this one says if P is in the interior of angle RST, then the measure of angle RST is equal to the sum of the measures RSP and angle PST. Okay, this is the angle addition postulate. We spent a lot of time on this one as well. Where in this example, we have an angle R, S, and T. Okay, so I'm going to put points R, our vertex S, which is always the middle letter, and the other side T. And it says that if we have another point P that's connected to S, then RSP plus PST is equal to the whole thing of RST. So it's kind of the same idea as a segment addition postulate. First chunk plus a second chunk equals the whole thing. Okay, now these terms are all going to be from chapter 2. So everything before this was from chapter 1. This is from chapter 2. The first one we have is the 2-point postulate. Okay, and this one says through any 2 points, there exists a line. Okay, so if you start with 2 points, then there must be a line connecting them. Okay, so start with points. and then you get a line. Okay? The next one is the line point postulate. And that one says if you have a line, then it contains at least 2 points. So the diagram is going to look the same where you have a line with 2 points on it. But in this one, you start with a line, then you get the points. Okay? On the back side here, we have the line intersection postulate. And that says if 2 lines intersect, then their intersection is exactly 1 point. Okay, so if you have 2 lines intersecting, they touch or they intersect at exactly 1 point. So if you have 2 lines, then you get a point. Okay, the next one is the 3-point postulate. And that one says through any 3 non-collinear points, there exists exactly 1 plane. So if you have 3 non-collinear points, which non-collinear means that they are not on the same plane, so if you have 3 points, okay, and non-collinear points mean that they are not on the same line, then there must be a plane, a flat sheet, that contains all 3 of them. Okay, so with this one, you start with points and you get a plane. Okay, the next one is the plane point postulate. And this one says a plane contains at least 3 non-collinear points. Okay, so this one, if you have a plane, then there exists at least 3 non-collinear points, again, that are not on the same line. Okay, so again, the diagram looks exactly the same in these last 2, but this one you start with a plane and then you go to the points. Okay, the next one is the plane line postulate. Okay, and this one says if 2 points lie in a plane, then there must be a line containing them that also is in the plane. Okay, so this one says that if you have a plane and 2 points in that plane, then there is a line that goes through those points that is also on the plane. Okay, so for this one, if you have a plane and 2 points, then you get a line in the plane. Okay, so only 2 more. This next one is the plane intersection postulate. And that says that if you have 2 planes that intersect, their intersection is a line. Okay, so I'm going to draw 2 planes intersecting. Okay, and then their intersection is a line. Where those 2 planes intersect, we get a line. Okay, so for this one, you have 2 planes and you get a line. And then the last one here is the linear pair postulate. We use this on our homework from Tuesday. And this one says if 2 angles form a linear pair, then they are supplementary. Okay, so if we have a linear pair, which remember is just 2 angles that form a straight line, okay, this will be angle 1 and this will be angle 2, then it says that you can add angle 1 and angle 2 and have them equal 180 degrees because that is the definition of supplementary. Okay.